Everyone. So in this video, I try to explain why we need the class to do the programming in Python. But for the first 2 minutes, I'm gonna go through the so-called the general purpose programming language, compare the Python and R. So for the people who are not interested to program in Python, especially for the class, you can just watch the first 2 minutes to see what's the difference between Python and R. Okay, let's just go through the definition of the Python. So if you just go to the Wikipedia, you will see the Python is interpreted high-level general-purpose programming language. So the general-purpose programming language is the key thing. The other thing is very important for Python. Its language is construct and object-oriented programming. You can just go to Wikipedia to see. But I want to talk about the general-purpose programming language. So I will not read the definition, but let's see some examples. So for people who have no familiar with C and C++, and the people might have heard about Fortran is very old and traditional programming, and you might have heard the Java and JavaScript and Julian, and then again the Python, also the PHP. So, but you will not find the R programming. Nowadays, a hot topic for people who are really interested in the data science, and MATLAB from the engineering side. So both those two programming language, MATLAB and R, they are not general purpose programming language, which means you will not expect some guy or some girl anyone who come to talk to you to say, okay, hello Michael, so today I just design computer games with R programming. Do you want to play my games on my laptop? Or some guy, some dude just come talk to you. Okay, I developed the mobile phone apps, the iPhone apps with MATLAB. You will feel seriously you can use MATLAB to design the mobile phone apps. You don't expect those situations happening in the real life. But a lot of apps, they can be designed and developed with Python. A lot of the computer games, a lot of apps, for example, the apps I'm using right now is called Atom. It's designed with C++ and Python. So you see the general purpose programming language, you can use it to do a lot of things, even do the web design, some graphic stuff. You can design the apps. You can also do the scientific programming, like people have done for the science. People have done for the statistic learning with R programming. Okay, let's just take a look. Like, what's the difference when you use those programming? Like, how the principle of those programming will affect we use a different language. Firstly, let's look at Python. So every time you see when you use Python, you have to import a lot of stuff. You import NumPy at NP, you import the pandas for the data science at PD. All those packages, they are kind of the meta class. So they are just a very, very big class. You can take it as a manufacturer. So for example, the pandas is a big manufacturer for you to deal with the data. You transfer it to data frame, you select, you filter the data, and the NumPy is for the scientific programming. You have to import this package because, again, the basic Python program is a very raw program. You can use it to design a lot of stuff. So now we use the pandas is a meta class, or you can also call it package if you are familiar with R. So you import it as a meta class and you read the dataset. So those dataset I'm reading is called the prostate. It is in the CSV file format. So once you read it, you want to print out the first 5 rules to take a look. So you call the head function. You see, when you call the head function, firstly, you have to type the prostate, which is the variable name. When I assign this CSV file, I call it prostate. And then you type the dot, and then you type the head function. So the dot, every time you type the dot, you actually call a function inside the class. Because those things you will not see it in the MATLAB or the R programming. We use the same data. It's called the prostate CSV. We read it in the R program. You read it, and you want to see the first several rules. You just call a function. You call a function called head function, and then you put the variable inside the function. So most people are familiar with MATLAB and R. They are getting used to this, which means you call a command or you call a function, and then you put the variable into it. like even you know the stata, you type the command, you put the variable after the command, and then it gives you a result. So again, we can call the summary in the R to see, give you the summary of this. You can see we got the minimal value, median, and mean. But you want to apply the same function in the Python, you type the variable name, you put the dot, this is info, and you can here summary. Okay, there's no object. You see there's no attribute, it's called a summary. So which means that inside of this class, they didn't define this summary. Actually, I think they define called summarize. Let's try this one. Okay, never mind. I forgot the in the pandas the packages. So that's why you feel the difference, right? In the R, especially if you only want to focus on the data science, the command, also the function is very easy to memorize, easy to remember. But in the Python, sometimes the way they design the function, the inside the class is not that straightforward. So let's see, what is called in the pandas? It's called the describe. Okay, it's not the summary. It's called the describe. So we call this describe. You got the same thing. You got the mean, standard deviation, minimal value, and max value of all the variables. It's exactly same when you call the summary in the R. Okay, you see the difference, right? When in the R, you just type the function, you call it. In the Python, you have to type the variable names, you type the dot, and you call the function inside the class. But why it is helpful or useful to use the class? Think about this, okay? Imagine you have the different package or different things. One day you came up with a very good idea to do the statistical learning. You want to write a bunch of functions to apply with the data science. But you will realize a lot of command some people already have used in a program. For example, we have the summary here. If you want to write the different function in R, either you have to put something like, for example, we call it the data science summary, right? But what if we have the class? If we have the class, every time I can still use the summary, but give it to the class like this. So, but of course, it doesn't work in the R. So I can show you when the library, for example, the 30verse package. So this is the package is heavily used for the data science. You can see when we library it shows the warning. So the Dipler filter mask status filter, which means both package status and Dipler, they use the same function name called filter. But when you call the different package, there's a contradict between those names. But those things will never happen in the Python because you always put the function inside the big class. That's why you type the variable name first, prot, for example, any variable you name it, and you type the head function or the filter. Those functions, you name it in the class, will only work inside the class. You don't have to worry about, okay, if I call this function, will it affect the attributes of other things? It will not happen because this function only works for this class. That's why, so the boundary is really clear for the Python. Okay, but why the class is so helpful for when we do the programming? So I will just use one example to show you why we need the class. Now, suppose you want to do the ordinary least square function. You want to write function to estimate to do the regression, right? So most people from the economics or statistician department, they know the function. Of course, we can just write a function, you define it, you estimate, for example here, you define the estimate function, you put the input x, and you do the linear algebra, you got to use this formula, the inverse formula to get the function. But what if we want to also print out the table of this estimator? You want to print out of the table of the coefficient, you want to print out the table of the standard errors, you want to print out the table of the t-statistic, you even want to plot. So of course we can write the several functions. The first function, estimate; second function, you plot; and third function, you give the table. And every time you call the different function, and then you do the different task. But can we put those functions into a big class and we call it every time? So that is why the class is useful. For example, I can define the function called estimate. I don't have to worry about whether this name is the same with other package or not. It doesn't matter. So I define the estimate and define the table. It gives the table of the your all estimations. And I also define some function like normalize, because sometimes you want to normalize your data first, and then you estimate the coefficient. You put it together called the class called OLS, right? So I can show you, once you put together, you can even add more functions later. You always call it OLS, and it works so simple. For example, let's do it here. So I change the working directory. You see I have the class called OLS. I define, but I have to initialize it. You can learn it later. I define the different function. I put them together, table, and then I just run it. So I have class now. Again, I read this still, we use the same dataset called prostate CSV. And then we prepare the training data. Okay, now let's fit the model. We fit the regression, right? Firstly, we initialize the class. We call the OLS, we initialize it, and then we do the estimate. Inside the estimate, we say, okay, we want to standardize the data first. You type the variable names. Here, the P Pro OLS is the class. So you type the variable names, you type the dot, and then you estimate it. You got the result, and you can call the table function, print it out. So we got coefficient, standard error, and z-score. And those are the list of the variables. You can even put the function of plot and call them. So this class is not that difficult. You just initialize it, and then you put any function you want. In most time you have, I believe the people who are interested on this video have write so many functions by themselves. You put that function, and you can also put an interaction between the functions. Inside this class, you call them. And so your code will become so neat. You don't have to worry about those, whether this name are contradicted with others. Because every time you have the class, you call the function inside the class. You can do whatever you want inside the class. You don't have to worry about the boundary things. Okay, now let's say we want to do the gradient descent for risk optimization programming. I assume you know a little bit, but if you don't know, it doesn't matter. Anyway, the idea is, firstly, we have to define the benchmark. So the benchmark is called the loss function. So here we have the square error loss, we have absolute error loss, we also have the Hilbert's loss. Okay, so the professor asks you, could you write all the three loss functions and to run the regression with those loss functions to compare the results of those regression based on the different benchmark, based on different loss function. Of course, I can write, for example, something I have done here. I can write the absolute error loss function. I can write the square loss function, put it here. I can write Hilbert loss function and put it here. And later, I can do something here. I define the gradient descent function again. I call the square loss function to run the regression, and give the result, and later I print the result. You see, the code doesn't look well. We can just put all those loss function, whatever loss function you put into the class, you define the loss function first, and then you define the regression, and then you define the other function, compare the different regression with those different loss function. You even can have the interaction between those loss functions. Then in the end, you can call the plot. So which means that your code are more organized with the class. That's why I like it a lot. Okay, anyway, I hope after this video you realize that the Python is really good with the class programming, or you can call it the object-oriented programming skills. I think it is enough now. Next video, I will try to show you compare the programming, the R programming and Python in a more detailed way, so you can see what you should do. If you want to do the statistics, you should just choose R. If you want to do the more broad task, you should use the Python. Okay, thanks for watching. Let's stop here. Goodbye.